Yes, can you see the screen? The solid edge software screen?
Yes, sir.
Yes?
Yes, sir.
Yes or no?
Yes, sir.
Okay, fine. Okay, so we were doing this problem in the last class. Okay, right. So what has been given over here? A triangular pyramid of 30 sides of base. So you have a triangular pyramid. Okay, the base of the triangle is 30 sides. Okay, and axis, that is the height of the pyramid, is 45 long, is placed on its base on HP such that the edge of the base is parallel to VP and nearer to it. So what he's telling over here, so you have to draw a triangle. Okay, you have to draw a triangle in such a way that, what is this? One of the edges of the triangle should be nearer to VP and it should be parallel, right? Okay, that is the condition he has given. If not, we could have drawn it like this also. But if you draw it like this, no edge is parallel to the VP, right? Okay, right. And next, what else he has given? Uh, right? Okay, a cutting plane inclined at 60 degrees to HP and perpendicular to VP bisects the axis of the pyramid. Okay, so we have a cutting plane, okay, which is going to pass, okay, at an angle of 60 degrees to HP, right? And it has to move from the observer towards the vertical plane, right? Okay, right? So now what we are going to do this, before we draw the cutting plane, we have to draw the front view for the pyramid. So what we will do is they'll project it from the top view, okay, from every corners of the triangle, project it, okay, and then what should be this height? This height should be 45 which is already given in the question, which is the axis of the pyramid, right? And now what you do is you draw the front view for the pyramid, join the corners from the apex, right? Okay, then after doing this, okay, after doing this, what you should do? Now we will come to the cutting plane portion. Okay, now what he says, cutting plane should be inclined at 60 degrees to HP. Okay, right? And it should pass, it bisects the axis. That means what? It passes through the midpoint of the axis. That means at mid height. So at 45 divided by 2. Okay, so this height should be that 45 divided by 2. How much will get? 22.5 So this should be the height of this. So in this particular place, what you can do is you can temporarily, you can draw one light line. Okay, keep your protractor over here. Yes.
So one of the edges of the base of the pyramid is parallel to
VP.
VP, right?
Yeah.
Yeah, okay, sir. Because the left-hand side drawing seems a bit weird, sir. That's it.
This one is side view. That will come to that later. Yes, still in
Yeah.
front and top view. Okay.
Oh, okay. Yeah.
Right. Then, so now what you can do is you can keep your protractor, measure 60 degrees, draw a line at 60 degrees so that it passes exactly at this particular point. See over here, it should pass exactly at mid height. Okay, right. So next, after drawing this cutting plane, now you find out which are the uh, point of intersection. That is, what is that? Where is the cutting plane coming in contact with the pyramid? So just look at this. Where is the point where these both intersect? Okay, so the cutting plane intersects on this edge A dash O dash. This is one point. Okay, then we have B dash O dash, that is another slant edge that is present. So cutting plane passes over there also. So that is point number 2. And look at the next one. It intersects at the base over here. Okay, It intersects at the base over here. Okay, but look at it carefully. Now it doesn't meet at the corner C. It is somewhere in between B dash and C dash line. Okay, it is somewhere in between that. Okay, and at the same time, now this line represents what? Okay, just a second. Okay, this line represents what? Now we have a line connecting from B dash to C dash. Yes or no? Which is the base of the pyramid. Hello?
Yes, sir.
Yes. So cutting plane passes through that edge. So there we get one cutting point. Okay, that is point of intersection, right? And then is C dash not connected to A dash? A dash C dash connection is there or not?
Yes, sir. It's there.
It is there. So there also there is one cutting point. No, that A dash C dash line is also here only. No, from A dash to C dash. I'll just draw it a little bit extra, isn't it? So there also this cutting plane is passing. No. Yes or no?
Yes, sir. Yes, sir. Yes, sir.
Right. That means two cutting points we have. One on B dash C dash, which is point number 3. Then another one is then the other cutting point is on A dash C dash, that is point number 4, right? So totally we'll have 4 cutting points. So see here, I'll show you. Now if you look at this, what is happening when this cutting edge passes? Say for example, I'll just draw it like this. Okay. Anyway, it's 60 degrees when it goes with respect to VP. Okay, we are just sliding from the observer towards the vertical plane. We are just slicing it like this horizontally, just assume. Okay, so we have the cutting plane initially over here. Now when we move this cutting plane, okay, in this particular direction towards from observer to the VP plane, okay, then what is happening? First the cutting plane passes over here. So it meets, it cuts the base edge A, B to C, that is point number 3. And then further on when it moves away in the same direction, it's going to cut on the AC line also. So we will get another cutting point, which is the point number 4. Right? So now looking at it carefully, look at this, what is happening? The cutting plane is passing over here, right? But this portion of the base of the pyramid is completely removed. The cutting plane does not come in contact with the corner C. Okay, right? So now what you are supposed to do is that, okay, now what we are supposed to do after drawing this, okay, now take the measurements, okay, from top view, that is from, sorry, what is the distance of the cutting points from the XY line to point number 1, from XY line to point number 2, then XY line to point number 3. Now how to get this point number 1, 2, 3? So for point number 1, not an issue. So it is given here only. See the arrow mark. After getting this point number 1 dash, 2 dash, 3 dash and 4 dash in front view, from 1 dash you project a line downwards vertically until it meets A O in the top view. Because where is this 1 dash? It is on the line A dash O dash. So this projection line from 1 dash should stop where in top view? It should stop on A to O, right? Then we'll come to point number 2 later on. Okay, Then point number 3 and 4. Point number 3 is where on B dash, C dash. So when you project it down, okay, you have to stop it on when it meets BC, the line BC. That is this particular line. Okay, so stop till there. And what about 4? 4 is the cutting point on line A dash, C dash. So for A dash, for point number 4, again the same projection line only, but you should stop it on when it meets AC. That will be point number 4. So in the top you give these intersection points 1, 3 and 4. Now coming to point number 2. Now for point number 2, I'll take it from the front view, that is 2 dash, and I will project until it meets what? B dash O dash, or until it meets in the top view BO. Where should I stop? Should I stop here, 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 here? How do you know? Right? So we don't know that, we cannot do that for that directly. Okay, and in this case, they have also asked in the question, draw the top and profile views in section. I want top view in section. I want profile view also in section. It is your convenient whether you take left profile plane or right profile plane, that we should make it suitably. Also draw the true shape of the section. Right. Okay. Now point number 2 is missing. Okay. So for that, now look here. What we have done, we have drawn the cutting plane in this particular direction. So if you want to see the cut portion, what have they asked? Draw the top and profile views in section, not just the top view or just the profile view with its section. So when I look from here, when I look in this direction, when I look in this direction, I can see side view plus what is this? This also gives me the section view also for in profile. Okay, profile view in section with cut portion I can see. So seeing in this, I will draw it over here as what? As x1 and y1. Okay, right? So this will be what? This will be left profile plane, right? Now for this you project it. Now what we are supposed to do after drawing the x1, y1 line, draw one 45-degree line. Okay, right? Now project all the corners, that is A, B and C up to here, take it to the left profile plane, and similarly from the front view, okay, A dash, B dash, C dash and O dash, project it. Yeah, draw these projection lines, then complete the side view. Okay, so we'll get by looking in from here, that means what? We are looking in this direction. Which are the edges that we can see? We can see B, C and O, right? A is going to be behind. So A dash, A double dash will be backside. It is going to be hidden. Now even if I see from here also, which are I can see? I can see C dash, I can see B dash, but not A dash. It is behind. Okay. So thereby A dash will be behind here. So once you get this, okay, make the required markings, give the alphabets, and then what you're going to do is from 1 dash, 2 dash, 3 dash and 4 dash projected to the side view. Where is 1 dash? 1 dash is on the line A dash, O dash. So here 1 dash, this projection line should stop on A double dash, O double dash, which is over here. So we get 1 dash over here, 1 double dash over here, then 2 dash is on the line B dash, O dash. So draw this line. So draw this line. Okay, until it cuts B double dash, O double dash line. Okay, and C dash, 4 dash will be here only, that we can take it from top view. They have given the arrow mark, right? They have given the arrow mark. So draw the projection lines in this particular direction. Wherever it means, that is the particular point. Now 2 dash, 2 double dash, from the side view, get it down up to 45 degrees. Okay, and then take it to the top view. Okay, now where is 2 double dash? 2 double dash is on the line B double dash O double dash. So this projection line should stop where it meets B and O in top view. That is this particular line when it meets, you should stop. So there you will get the intersection point. So now join all these 4 points 1, 2, 3 and 4 to 1. So that will give you a trapezium, and that is the sectional top view. And similarly over here in the side view also, join this 1 double dash, 2 double dash, 3 double dash and 4 double dash and 4 double dash to 1 double dash completed, and that is the sectional side view. Right? Any doubts till here? Hello?
No, sir.
Right? Okay. Now, the next important thing that you should remember is that in all the problems, after we draw the cutting plane, okay, right, the portion that is retained, see what is there after we cut, it becomes two pieces, right? So the portion that is retained should be dark in color. The portion that is not, that is going to be removed, the portion that is going to be removed, see this portion in which I'm drawing in blue color should be in light color lines. Okay, so just look at this. I'll uh, just remove all these things. So now look here, actually you have dark color line partially A dash to O dash, partially from A dash to 1 dash it is dark, from 1 dash to O dash it is a thin continuous line. That means what? From 1 dash to O dash, that particular portion is removed, isn't it? Okay, that same thing should be here also in top view, also in all the drawings. Okay, now if you look in top view, look at this, from A to 4 it is a continuous dark line, but from 4 to C it is a thin line. That means that this portion is removed. Similarly from C to 3 it is a thin line, and 3 to B it is a dark continuous line. And the same thing comes over here also in side view also. See here in side view, from B double dash to 2 double dash it is a dark continuous line. From 2 double dash to O double dash it is a thin continuous line. So these things you have to be careful, right? Okay, now coming to, now we have drawn the front view, top view and side view. We have to draw the true shape of the section. Now to draw the true shape of the section, what we are going to do first is, okay, draw one XY line, okay, parallel to the cutting plane at a particular distance. Keep medium distance, not too far or too close. See, outside the pyramid, leave some space and for a certain distance parallel to the cutting plane. Okay, then what we should do, draw projection lines. Okay, draw projection lines, draw projection lines from where? From 1 dash, in which direction we should draw? This angle should be 90 degrees. Okay, between the cutting plane and the projection line, it should be 90 degrees to draw the true shape of the section. Okay, right? Make it 90 degrees. So draw it again from 90 degrees, okay, from cutting plane, from point number 2 dash, and then another projection line from 3 dash and 4 dash. Extend it beyond the x1, y1 line. Now, after that, measure the distances from xy line to point number 1, xy line to point number 2, and similarly for 3 and 4. So if you take that particular distance, say for example xy line to point number 1 in top view, okay, keep that distance either in a scale or in a compass. Okay, measure that distance from here x1 y1 line to that particular length, on which line? On the line that you have projected from 1 dash. Okay, So if we are going to do by arc by compass from the center, from this intersection point on x1 y1 line on projection line 1 dash, okay, for that distance that you measured in top view, draw one arc. Okay, right? So like that, do it respectively. Similarly, for point number 2, measure the distance in top view. Okay, from x1 y1 line, measure it. Keep that particular distance. Keep a small dot for your reference. That will be point number 2. Similarly, 3 and 4, join all these 3 things. Okay, you will get the true shape of the section. Right? Any doubts? Any doubts?
No, sir.
Right? Okay. So, as I told you in the last class, do this problem. Okay. I've explained it. Okay. Last class also, today also I've repeated it. So try doing this. This is same as your first program. Only difference is side view also comes into picture. Okay. The side view also comes into picture. Right. Okay. Now we'll go to another problem. Okay. We'll go to a different variety of problem. Okay. Now what is there in this particular problem? A cube of 30 mm sides of edges is cut by a section plane so that, okay, now we have a cube of 30 mm edges. Okay, it is cut by a section plane. Okay, that cube is going to be cut. Okay, so that is what they're given. Now, what is the next portion? Now we should see how the cube should be placed. Till now we have not got it. Okay, in which way the cutting plane is passing, any angle to HP, or is it perpendicular to VP? What is it? They have not given. Okay, now let us continue. Now, continuing in the question, okay, so that the true shape of the section is a regular hexagon. Now, after we cut, okay, the true shape of the section should be what? A regular hexagon. What is telling? He is telling that, say for example, if I take this problem, I will cut this. Okay, I will cut this solid that has been given. Okay, I will cut it. In what way I'm going to cut? It is not given. Okay, it may be like this or it can be like this, whatever it is. But true shape of the section, this particular portion should be what? It should be I should get a hexagon. I should get a hexagon. A regular hexagon. Okay, equal sides. All the sides should have the same length in the hexagon. That is what he's telling. Okay, right. Draw the projections of the cube and find the inclination of the section plane with HP. Now, what is it saying? It's saying draw the projections of the cube. That means front and top view. Okay, find the inclination of the cutting plane. Now we should only find out in which way the cutting plane should be placed. How should I cut? Okay. Also measure the length of the sides of the regular hexagon. So the hexagon that we get, what is the side length? Each side, what is the length of the hexagon in the true shape? Now say for example, what is this question? Now you take a cucumber. Okay, I will tell you cut a cucumber. Okay, and you should get circular cross section. How should you cut?
Perpendicular.
Horizontal.
Huh?
Vertical.
Vertical,
Right.
sir.
So you have to keep your cucumber horizontally, right, completely flat, and move your knife from top to bottom vertically in a straight manner, perpendicular only. Okay, isn't it? So then you are going to get a circular cross section. So this question is also like that. He is telling what? You keep the cube, okay, you cut that cube, but the cross section that you are getting, the true shape that you are getting should be a regular hexagon. So now what is our job? We should know in which manner we should keep the cube and we should cut the cube also. That is our job now, right? So don't expect that always all the conditions will be given, right? Like the previous problem, they will only give how the solid should be placed, how the cutting plane is passed. No, that is one variety of problem. These problems are a different variety. Is that clear? Any doubts?
No, sir.
Right now, to how many sides does a cube have? How many sides does it?
6.
Six. What man? 6 sides. Huh?
8, sir.
8, no. Right. Now, when I draw the front view for this cube, how can I get, what are the possibilities? I can get a top view like this, like a square, isn't it? Yes or no? Then front view for this will also be how, if I project it, that will also be another square only. Correct, no? Right? 30 mm side length. Okay, this will be 30 mm. This will also be 30 mm. Yes or no? What is the other way that I can place a cube? The other way that I can place a cube is like a diamond shape in top view. Isn't it? Like this. Correct, no? Hello? Yes or no?
Yes, sir.
Correct. So how does
Yes.
this front view will look? I will be able to get something like this. Correct? So front view will look like this, top view will look like this. Now, for a hexagon, how many cutting points are, how many corners are there? For a hexagon, how many corners are there?
6.
6. Okay. Now, look at this. Say, for example, I will cut, just put it in a different color. I will cut the hexagon in this particular manner. Okay, in this particular manner. That means what? Now let me draw the projections. Okay, now I'll just zoom in only this portion. Okay, right. So now look here, at this particular point, okay, 1 cutting point, 2, 3. Yes or no? Correct, no? 3 cutting points. This is 1 cutting point of intersection on this particular edge, right? And then 1 more cutting point of intersection on this vertical edge. Then 3rd cutting point or point of intersection over here on the base. Okay. But for hexagon, how many we need? We need 6. Okay. Right. Now this is only on front side. Okay. This is only on front side. It has to go completely onto the other side, no? Right. So there again I will get another 3 cutting points. See in the top view. Cutting point number 1. I'll just put it in circle. here I have one point of intersection. Then on this vertical edge, it will cut, right? Somewhere on this height. So that also I can see in the front view, no, as well as in top view. So this will be point number 2. Then point number 3 over here. Then this is all on front side. Okay, if you look at this bottle, this is only these 3 cutting points are on front side. So when I take the cutting plane, okay, when I take the cutting plane, it has to go completely, right? I have to slice it into 2 pieces. So again, I will have cutting points onto the back side. Okay, so where are those cutting points? The 4th cutting point is here on this particular edge where the cutting plane intersects. 4. Then again, I have again this edge which is back side. So point number 5. Then here point number 6. For hexagon, how many you need? How many corners?
6.
6. Did you get 6 points over here? 6 point of intersections. Yes or no?
Yes, sir.
Correct? So
We got
this is the way in which I should keep the cube. Only then I will get 6 cutting points. If I keep it in this manner, I will not get it. If I cut like this, okay, and I'll project it. How many cutting points are there? 1, 2, 3, and 4. 5 and 6, not there. I don't get it. Okay, right? So even if I'm going to do it, even if I'm going to do the cutting plane like this, okay, and I'm going to take it over here on this particular edge, and here. Okay, it is going to cut somewhere over here, 1 point, sorry, 1 over here, maybe another one over here, and other one over here. Still, I will get only 4 points only. I will not get 6 points at all. So I will not get a hexagon, right? So the way we have to keep the cube is like this. Okay. So let us start drawing this, and then I'll continue. I'll let you know how to draw. Okay. So let me draw one XY line. Okay, so let me draw the cube first at 45 degrees, 30 mm sides. Okay, 30 mm, height 30 mm, angle should be how much? Angle should be 90, 135. Okay, so minus 135. Okay, now just measure this angle. Let me show you. See, at 45 degrees with respect to the XY line. Okay, right? So draw the projection lines from every corner. Okay, now draw the front view for this. Height is going to be how much? What is the height of the cube? 30 mm. Okay, 90 degrees. And this, so let me give the alphabet. So I'll give A1, that will be at the base. Okay, and on the top corner will be A. So here we'll have B and B1. Here we'll have C and C1. Here we'll have D and D1. Okay, so B1B is a vertical edge which can be seen in the front view. Okay, right? So make that a dark line. Right. Okay. Now what should we do? So we have done this. The height of this is going to be so much. Now next thing is that we should get a regular hexagon. We should get a regular hexagon. So the trick for that is that, okay, now where should the cutting plane move? Yeah, the cutting plane, now we know that it should come to these 6 points. Where is that? Okay, now the cutting plane should be in such a way that, okay, it should intersect where half of this line. It should intersect on half of this line, half of this line, half of this line, and half of this line. Right? That means what? Half of this will be where? Now if I project it, say for example, midpoint for this line, see it is here. Midpoints. See, midpoint is here. From here, if I draw one line, so this is, or it should be the midpoint of this particular line, or here, right? Midpoint of this, within this. Okay, let me split it up. Either this way, or the easiest way is midpoint of this. See? Midpoint of this portion, then again midpoint of this portion, right? And then midpoint of this portion. Okay. So that is what we are supposed to do here. If we do like that, then we'll get a regular hexagon. Yeah, so let me draw this line once again, this base also once again. So from here to here one section, from here to here other section. Okay, now I'll go take midpoint of this particular portion, midpoint here.
Sir,
Okay.
what is the cube dimension, sir?
30 mm.
30. Okay.
Yeah. Yeah. Right, so somewhere it has gone wrong. Right, so I'll take right, so midpoint of this line. How much is this line? 21.1. So let me see whether it's all right. So what we can do is that, so say for example, when you're drawing it, you can measure it in your scale. Okay, keep a small dot. So I'll just draw a line. Okay, or on the system when you're going to do, you can also keep a small dot at a distance. Okay, 21.1, no, half of that. 21.21 divided by 2. Yeah, angle 0 degrees. So 10.61. Yes. Okay, so from here 10.61 angle 180 degrees. Yes. Okay. So and this height, it should be mid height of this. What is the height? 30. So at 15 mm 90 degrees. So now I'll just connect this all these 3 points. Look here. Okay, now I'll just extend it. I'll just give extend to next. Okay, and I'll change these things to axis line, sorry, cutting plane line. See, now here, what do I have? Okay, here I'll give the naming. So this is going to be A1 dash. Okay, this is B1 dash. And here we have C1 dash. Put it here outside C1 dash. And here backside we'll have here we'll have D1 dash also. It will be backside. Yeah, and here we'll have A dash. This will be B dash and D dash. Here we'll have C dash. Yeah, right. So this cutting point, this intersection place, point of intersection. Here we'll have 1 dash. This is going to be 2 dash, and this is going to be 3 dash, which is on the front side. Okay, and then on the back side, go in a circular manner. So we have onto the back side here, we'll have 4 dash. Okay, here we'll have 5 dash, which will be hidden. And here we'll have.
Sir, the cutting plane is 60 degrees, no, sir?
No, that we should see. We don't know.
Oh, we should find out.
Yeah,
Then
yeah,
how do you draw, sir? Again, if you can tell.
yeah. I'll tell you. See, what we'll do is that, okay, we want what regular hexagon, correct? All the 6 sides should be equal. Now for the cube, the base sides are equal. Hello.
Yes, sir.
Yes, height is also same as base edge only, no?
Yes, sir.
Correct. Okay. Now that means in this front view, horizontal line and vertical line doesn't matter. They are both of the same length. Correct. Now, if I take half of this horizontal line, okay, only this portion, then half of this vertical line, then half of this horizontal line, right? Yes or no? Correct. So I am
Yes.
going to get three cutting points, no, point of intersection, 1, 2, and 3. Yes or no?
Yes, sir. Yes, sir.
Correct. So where is it? It is cutting midway of, just look at this. It is going to cut midway of this 30 mm line, correct? Then midway of this 30 mm line, midway of this 30 mm line, and midway of this 30 mm line, midpoint. Okay. And similarly, one second. And now similarly in the vertical edge also, where have we cut? Half of the height. Yes or no? Correct? Everywhere half of the distance. So when I join all those things, what should I get? When I join from 1 to 2 and 2 to 3, it should be same distance only, no? In true shape. Hello?
Yes, sir. Yes, sir. Yes, sir.
Correct. I'm not doing it here over here. Half of the horizontal line, 1/4 of the vertical edge means then the distance will be varied. Yes or no? Say for example, if I'm doing it like this. Okay, if I'm doing it, say for example, I'm doing it like this. What is the distance from A to this cutting point? Okay, very large. Okay, what is the distance from C1 dash to here? Okay, something
Yes, sir.
different, no? So the
Yes, sir.
lines,
It's
true shape line
very.
will be different, no?
Yes,
Correct.
sir.
So if I take everywhere midpoint, 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 it should be the same length. And also at the same time, the cube has also got all the sides same length only. So it will not vary. Okay, right? So now what you're going to do is that, now what we'll do, now this particular thing is over. Now we'll project these cutting points to the top view. Okay, we'll project it from the intersection point. Yeah, sorry. Okay, one cutting, one projection line, the other one from here. Okay, now look, now see the top view where and all it is going to cut. Okay, point number 1 will be on A1 dash, sorry, A1 B1, right? That means it will be here 1. Point number 2 will be on B1 C1. So 2. Point number 3 will be here on this vertical edge C1C only. So there I'll have 3. Then going to the back side, that is from C1 to D1. Okay, so here I will have point number 4. Then on D1B, there's one vertical edge which it will slice. So here I will have point number 5. And point number 6 will be where? On AD, that is on the top surface, right? So here I will have point number 6. Okay, so I joined this particular thing with a dark continuous line from these intersection points. And this is already joined, and from here to here. Okay, so I'll just view this. and this particular portion. Okay, that is 2, 3, 4. This particular triangle, okay, will be a light line. So I'll split it off. I'll split this line, and again I'll split this particular line. Okay, so that this particular portion will be in light color because this particular portion will be removed. Okay, it is going to be removed. So just look over here. See, the cutting plane passes over here only. It does not pass over here in this region. No, it doesn't pass. So this is going to be removed. This portion, whatever is over here, this portion that I'm going to shade now. Okay. So here in this portion, all this will be removed, right? So this particular portion should be in light colored lines only. Okay, so what we are going to do is that I'll select this, sorry, okay, we'll split this. Mm. Okay. So from here onwards, it's going to be a light line only. And this particular portion, here it will be dark. In this particular portion from 4 to B1 dash, it will be a dark line. Okay, and this line, and this particular line will be light, this half. Right, only this particular, see this line, here, here, and this will be dark because the remaining portion is removed. Okay, now what we are supposed to do, now you can measure, you can take a protractor. Okay, now you can take a protractor and measure what is the angle. Right? Okay, now draw a parallel line to this. Okay, I'll offset it. Okay, I'll offset it, and I'll give extend to next. Okay, now what we are supposed to draw, now first thing that we are supposed to do is that after doing this, we have to measure the distances in the top view, okay, from XY line. Okay, so for that, okay, all right, so let me see whether it works out. So from here to point number 1, and then from here to point number 6. Okay, then again from here to point number 4, and then from here to point number 2. Plus we need one more, that is from XY line to point number 3. So these things we require. 1, 2, 3, 4. 1 minute. Sorry, 2 should be here, not 3. Sorry, very sorry. It will be here. 2 will be here. 3 will be here. 4. Not this distance. Okay, we require this particular distance. don't show this dimensioning lines in the drawing. Okay, I am showing it to you over here because you should know from where to where we have to measure. Okay, right? Okay, so we have taken all the 6 measurements. Okay, point number 5 is also there. At point number 5 we require. So this is for point number 1. This is for point number 2. This is for point number 2. This is for point number 3. This is for 4. Then this one is for 5, and this one is for 6. Okay, now we'll transfer these dimensions or these measurements over here. Okay, so we'll draw a projection line from perpendicular to this cutting plane. Okay, for a particular distance, or we'll keep it only up to XY line. Okay, and I'll make sure that this angle is how much? 1 second. This angle should be 90 degrees. Okay, yes, it is 90 degrees. So now I'll do the same thing to the other 4 places also, from 2 and then from 3 and 4. There's a small projection.
Sir, what's the offset distance you took?
I have taken it as 40 mm. See, the thing is that what you should do is when you are going to take this offset distance, okay, when you're going to draw this x1, y1 line, yeah, just a minute. When you're going to draw this x1, y1 line, okay, now you ensure that this line will not intersect over here. It will not pass like this. It should be outside the solid. Okay, that's all we need. It should not overlap on the solid only. Is that clear? That should be your distance.
Okay, sir. Okay.
Okay. Now coming back to this, what is point number 1? How much is the distance? Okay, point number 1 distance is how much? 1 second. Okay, point number 1 distance is what? 50.11. So 50.11. Okay, and it should be parallel to the projection only. Right? Okay. Then point number 2 is at a distance of 60.72. Okay. .72. Okay, parallel to it only. Then point number 3. How much is point number 3? 50.06. Okay, now point number 4. Point number 4 is on this line only. So point number 4, what is the distance? 28.48. Sorry, 28.84. So 28.84. Okay, then point number 5, 18.3. Then point number 6, what is the distance? 28.9. Yeah. Look here, I'll show you. This is point number 1, 2, 3, and then 4, 5, and 6. So join all these by straight lines. Okay, Now I'll join all these 6 points. Right? Okay, now I'll show you the measurement. Okay, so maybe probably I have not drawn it exact, somewhere the projection line is missing. Okay, so you should get the same length. Okay, in all the places. Okay, in the system, I have not drawn it exactly. Okay, exact projections from the starting from the sorry. Yeah, can you hear me?
Yes, sir.
Yes. Okay. So now look here. So the thing was that, see here, yeah, you can see this difference, right? So see, I've not drawn it exactly on the XY line. Projection line is not starting from this corner, right? So like this mistakes are there. Okay. So thereby that is the reason why I am getting different lengths for the hexagon. Okay. But you please draw it
The
correctly.
screen is
Okay.
not
Your
visible.
screen is not visible. Huh? 1 second. Okay, now
Yes, sir. Sir,
now you're
I
in.
got the polygon, sorry, so hexagon full, I got it as 21.21, sir.
Okay, yeah, right. Okay, so then it is correct, right? Okay, right. Any doubts? Any doubts? Right? Okay, so we'll go to another problem which is similar in type. Okay, another similar problem. We'll see that problem over here now. Okay, so the next problem is going to be what? A square pyramid. Okay, that means the base of the pyramid is square. The edge length is 50 mm. Okay, and the height is 70 mm for the pyramid. Rests on its base on HP. Can you see the screen, all of you? Yes or no?
Yes, sir.
Yes, okay,
Yes, sir.
right. With one of its base edges parallel to VP. So we have to keep a square base of the pyramid on HP, and one edge of the square should be parallel to XY line. Okay, it is cut by a section plane such a way that, okay, the true shape of the section is a trapezium. Okay, cutting plane is going to pass over the pyramid. That is what he has given. True shape should be a trapezium. Okay, whose parallel sides measure 40 mm and 20 mm. That means for the trapezium, there are two parallel sides, right? For a trapezium, if you look at it, for a trapezium, okay, it will be like this. Okay, 1 second. Now, which are the two parallel sides? One is this and this. So, one parallel side is 20 mm, the other parallel side is 40 mm. Draw the front view, sectional top view, and true shape of the section. Okay, so we have to draw the front view, sectional top view, and then true shape of the section. What is the inclination of the section plane with HP? Is asking what is the cutting plane angle to get this particular trapezium shape. Measure the perpendicular distance between the parallel sides in the true shape. That means what? Is also asking what is the distance between these two parallel sides in the true shape. What is this distance? If I have 20 mm here and 40 mm here, then what is this height? Okay, that is also we have to measure. Okay, right.
The previous one also is like we have to find the section plane angle, no, sir.
Which one? Which one?
Previous one, sir. The
Okay.
hexagon.
Yeah. Okay.
We have to find the angle, no, sir.
Yes, we have to find the angle. That is what I've indicated here, no?
54, sir.
Yes, 54. Okay. Right. Okay. So now what do we have? We have a square base pyramid of 50 mm sides. Okay. So let me start drawing it. Okay. So first I'll draw one XY line. Okay. Then let me draw one square whose side is 50 mm. Okay. Now for this pyramid, okay, I'll connect it the opposite corners because pyramid when I look from top, it will look like this in top view. Correct? Right? Now I'll draw the projection lines. This is 90 degrees. Right. So let me give the alphabets. So here let me take A, here B, this one C, and this one D. And let this apex be the O. Okay. Right. Now after this, I'll draw the projection for the front view. and from here it will be the axis line. What is the height of it? Height of it is 70 mm. Okay, now I'll connect it from the apex to the base corners.
Sorry, square of 50 mm,
Yes,
sir.
a square of 50 mm. Okay, now what is the condition given for the trapezium? For the trapezium that we are going to get. Okay, it should be parallel sides. Okay, now parallel sides, one side should be 20 mm, the other side should be 40 mm. Now for this case, what I should do, I will cut something like this. Now when I cut something like this, what is going to happen? What will happen? Now look here, I will get, okay, I'll put the naming so that you will understand. Okay, I'll have A dash here, then B dash here, and then C dash will be at the background, that is behind, so it will be hidden. And here I will have D dash. This will be D dash. Here I will have O dash, which will be hidden. That is the base of the axis line, one end of the axis line. Yeah, and at the apex, sorry, at the base it will be O1 dash. O1 dash. And on top, here I will have O dash. Okay, now look at this. See, this line is what? A dash O dash as well as D dash O dash. This line is what? B dash O dash as well as backside we have C dash O dash. So the point of intersection where the cutting plane intersects this, it cuts two slant edges. This cutting plane cuts A dash O dash. So I will get point number 1. That is 1 dash. As well as it is going to cut another line, that is D dash O dash. Okay, so let me come in circular manner. So 1 dash, so then B dash O dash, this here, this cutting plane is going to cut. So I will have 2 dash, 2 dash. Then backside we have C dash O dash. So there also it is going to cut. So point number 3. So 3 dash. And then D dash to O dash is also going to be cut. Okay. So
can you explain again, sir?
yeah,
Triangle ಮಾಡಾದ್ಮೇಲೆ.
I'll come. What do you want after triangle? This cutting points,
Sir,
huh?
yes, sir. After the front view, the section plane in the sir. I didn't understand. Like I didn't listen.
I've just drawn the section plane for our assumption. Okay, right? Okay. So how many cutting points? Now we have, what is this line? A dash O dash, no? This line.
Yes, sir. Yes,
Correct.
sir.
Okay. Now look at this. So when I look from here, I can see A dash O dash. Okay. D dash O dash is behind, no? Correct. So this line itself is again D dash O dash also.
Yes, sir. Correct.
Correct.
Sir.
So if you now look here in the screen, look at the camera. So if I cut here, front side I am cutting. So I'll get A dash, O dash, I'll get one cutting point. Now
Yes,
when I
sir.
slide further on, I have another edge backside.
Hmm.
So there I will get another cutting point,
Yes, sir.
right? So
Yes,
similarly,
sir.
here I will get what? I will get one cutting point on this line, I will get one cutting point on this line,
Correct, sir. Yes, sir.
right? So similarly, now go to the other side where the cutting plane is going to intersect where B dash, O dash, C dash, O dash.
No dash. Yes, sir.
So I will get
Yes,
another two cutting points, correct?
correct, sir. 4 points we got, sir. Yes, sir.
Totally 4 points. For trapezium, how many we have? We have 4 corners, no?
Yes, sir.
So we should have 4 cutting points. So did we get 4 cutting points?
Yes, sir. We got, sir.
Yes, we got it. Okay, correct?
No,
So
like when you drew the section plan, sir, you just like
I just randomly drew it.
okay, okay, sir.
Correct? No, that I have
Yes,
drawn
sir.
it only for your understanding. Still, I have not gone how to draw the cutting plane. I am
Yes, sir.
only telling, can we have the cutting plane like this? That is
Yes, sir.
what I am looking. Okay. Yes,
Yes,
we can
yes,
draw the cutting plane like this. So thereby, we will get 4 cutting points. Is that clear? Now,
yes,
as
sir.
per the given condition, we have to start drawing. So I have what I can do. So I can have this 20 mm and 40 mm correctly. So where will this cutting point come? Say, for example, if I take like this is over here, no? Second. From here. Okay. Where should I stop? I should stop on this slant edge only. Correct? No? Right?
Yes, sir.
Yes, I should stop on this slant edge. And then here. Okay. Now the trick is that what are they telling? If I draw like this, say I'll complete this one also. Now what are they telling? Now these two are parallel, no? This and this line. Right? This and this is parallel, no? This particular portion and this particular portion.
Yes, yes, sir. They're
Yes.
parallel.
Now if I keep this distance, sorry, not angle, distance between.
So the pyramid height is 70, sir.
Yeah, pyramid height is 70. So now if I have here, if I keep this as 20 and 40, and if I join it over here, what am I getting?
Trapezium.
Trapezium. That is the condition, no? Right? But the thing is that I should get 20 here and I should get 40 here. Okay, I should get 20 here and 40 here. Okay,
Yes, sir.
right? So before drawing the cutting plane, okay, I've just drawn it so that you understand. Okay, but how to construct it? First, we should, in this case, we should draw all the 4 corners from the top view. In the previous problem, you look here. In the previous problem, we did the cutting plane in the front view, found out the points, projected bottom to the top view. But in this case, we have to start it from the bottom for construction purpose. For understanding purpose only, till now I have drawn. Okay, right? So now let me do the actual construction. Okay, how to get this trapezium in top view? Let us see. Somewhere something has gone wrong. 1 second. here it should be 70, 90 degrees. Okay, yes. So now let me draw it. Now what I will do, I will draw one line. On the system, you can do like this if at all you want. Otherwise, what you can do is that you have to do like that, right? So 20 mm, you have to get 40 mm, correct? Okay. So okay. So when you're doing it on the uh, on your sketchbook, what you can do is go to midpoint, or you draw one horizontal line from here. Okay, keep your scale like this. Okay, keep your scale like this such that you have 0 on this line on C to O. Okay, and then as you move the scale gradually along this line, keep 0 here only, keep it like this parallel to the C. This line should be parallel, this edge of the scale should be parallel to this side BC only, and slowly move it along this line so that what you should have, this side when you move on this line, here you should have 0. At some particular point when you move, here you will get 40 mm, 4 centimeters. There you stop and draw that line. Hello? Is that clear? Is that clear?
Yes, sir.
Yes? That is one way of drawing it. Okay? That is one way of drawing it. We have to find it out. Okay? Right? So, if you know that, you can do it. I do that by that method. I feel that is easier. I just take the scale. Okay? Keep that 0 of the measurement on this particular slant edge. Keep this edge of the scale parallel to BC, start moving it gradually over here so that just see at every moment. Next moment you keep your scale over here. Okay, see here it should be 0 here, and if on this particular edge you are going to meet with the 4 centimeters or 40 mm. So once it meets, you stop there, draw the line. Okay, you draw the line. Similarly over here also, on this place also you keep your scale like this. Okay. You keep your scale like this so that 0 will be on this particular line. Start moving gradually inside so that here you will have 0 and here you will have 20. Draw the line. So once you get that, what you can do is you can measure what is the distance. So once you get that distance, you can easily draw it onto the system. So what I will do over here is that I will go by a different method over here, by approximation method. Let me go. So I'll take up a line for a length of 40 mm, 90 degrees. So I will see where it suits. Mm, 40 mm angle minus 90 degrees. So let me check. Does not joined exactly. No, there is a small gap over here. So that means I have to move it a little bit closer. Since I don't know the distance, I'm drawing it like this. Once you draw it on your sketchbook, it's easy. Okay, still there is some gap. Okay. Yeah, yes, can anyone measure the distance and tell me how much is this distance? I want this particular distance. What is the distance from here to here? Anyone?
One minute, sir.
Just the other way.
Sir, 4.5 mm, sir.
4.5 mm. No, if I
Yes,
draw
sir.
4, if I draw at 4.5 mm, there'll be a gap. How much did you take square size of
50,
this?
sir.
15, no?
50, sir.
50. 4.5, it will be too small, no?
I'll
4.5.
just see because even I was doing on software, sir. When you told to do, I just did it on.
4.5 means it will be somewhere over here. That means the gap will be more. This line will
Yes, sir.
not be, this line will not be, then it will not be 40 mm. It will be more than that. Right. Distance 15 mm. Let me see what is this. This line should be 20 mm.
Sir, 5, sir.
5, huh? Okay, let me
5.
see. Let me see. For 5 distance. Okay, here almost, yes, there's a very small gap. Okay, and here this distance. Okay, so here I think it has gone
Yes, sir. It's
beyond,
cross.
it has crossed it.
Cross. Well, around 4.96, I guess, sir. 4.96, 4.96.
Okay, must be here. All right, let me do it. Okay, yes, it does touch it over here.
Yes, yes, sir. Now it's
Right, so similarly, you do it on the other side also. Okay, so this line is going to be what? This length is going to be 40 mm. This length is going to be 20 mm. Okay, the slight thing is there. You please draw it properly. Okay, and now join this pyramid.
so. What's the distance between?
Probably around 15 mm. Instead of this, no,
40 there.
the best thing is you please follow this method. I told you, no, take a scale, right? Keep this corner of the scale onto the slant edge, parallel to this A dash AD line. Okay, and you
Yes,
just gradually move along this line. So that zero should always be on this line. Okay,
yes, sir.
and once it,
But when doing in software, sir.
yeah, doing on software, I'll tell you. Once you get this onto the once you get it onto the system, okay, okay, once you get it onto the sketchbook, what you do is you measure what is this length. Say for example, from here to here. What is this length? From D to, I'll just put this as point number 1. This was going to be anywhere point number 4. You measure what is the length on D to 4 in your book. Keep a scale on this line, measure this distance. Okay, right? Come to the system, draw this line over here. Say for example, you are getting this particular line as say for example 21.6. Okay, 21.6 mm. You draw one line, or at that particular point, you after that particular distance, you keep a small dot. Okay, you keep a small dot. From there, you draw 20 mm line, or else you take after you get this point. Okay, after you get this point, the other method is take arc by center, keeping this as center. Okay, distance is how much? 20. So that will be the radius value. Cut an arc on this line. Is that clear? Hello?
Yes, sir.
Yes, clear, right? Okay. Okay, so here we have point number 4. Let me put that. Point number 4. And here we'll have point number 2. This will be point number 3. Okay, now connect this. See, now trapezium, this trapezium will look like what actually? Okay, this trapezium, okay, okay. Now this, can you tell what is the true height of the trapezium? Can you tell the true height, or what is the exact distance between this line 1, 4 and 2, 3? Yes, can anyone tell? Right? So what they want is the true shape. Okay, now we have got only trapezium, but it is the apparent shape. Now what we are supposed to do is that after drawing it in the top view, okay, go for projection line from here, project it to the top view. And from here also, Okay, now just extend this. See, where is it cutting? It is going to cut here, and this is going to cut in this particular place. Now join this. Okay, now join this by a straight line. Right, so I'll just draw one line over here. To extend to next, here also extend to next. Now look here. So there you have point number 1 and 4. Okay, and here you have point number 2 and 3. Okay, now what is the angle that they are asking? They are asking what is the angle, right? Now measure this angle. Right? So it is going to be at 43 degrees approximately. Okay, not 43 because I have not drawn it exactly. Okay. Now what you're going to do? Now this portion of the pyramid, let me split it off. And here, and this should be light. Now I'll go to offset. I'll offset this by distance of, okay, yes, it goes above the pyramid, fine. Let it be there. Okay. Now what I'll do, I'll draw the projection line at 90 degrees. Let me see the angle. Make it 90 degrees. Okay, yeah. Now keep this, move it here. Okay. Come back over here. Okay. So let me measure what are these distances. Okay. Now I'll go to this distance between XY line to point number 4. Then XY line to point number 1. Then XY line to point number 3. Then XY line to point number 2. Right? Okay, now for these distances, let me draw the line. How much is point number 1? 53.4. 3.44. Second, what is this angle? 47.1. Okay, then another line. What is this distance from XY line to point number 4? 33.44. How much it is? 33.43. Okay. So from here, point number 2 is 63.47. And point number 4 is how much? 23.47. Okay, so let me make it. continuous lines. Okay. Now let me join all these four corners. And hatch this. So this is the trapezium. So if you look at this, this should be, even if you measure for this particular line, yeah, I think I've not drawn it exactly on the line. Okay, so again here you should get 20 mm and 40 mm, and this distance is what they are asking. What is this distance? Sorry. What is the distance between these two parallel lines? You have to measure what is the distance from this. Okay, what is the height of this trapezium? You please measure it. Okay, I'm not getting it over here. The software is not giving me that option. Something is wrong. I'm not able to get it exactly. Okay, let me do it. No problem. Still do it. Split it over here. And split. Yes, I want this. So this should also be actually at around 40. If your measurements are correct, it will come at around 40 mm. Okay, I have not drawn it exactly. Okay.
Sir, I got the section angle as section plane angle 45, sir.
How much?
45, sir. ನಿಮಗೆ 43 ಬಂದಿದೆ.
Howda? Okay. No, I have not drawn it exactly.
Yes, sir, yes.
Slightly it is not adjusting onto the software exactly at the coinciding points. So you please do it carefully. Okay. Right?
Yes, sir.
Right. So here I got here 20.01. Okay. Why? Because why did I get that 20.01? See here also 1 to 4 is 20.01. If you have maintained it exactly at 20, in the true shape also you will get 20 only. Okay. Right? Okay. So this is how you are going to do this problem. Is that clear? Yes. Any doubts? Any doubts?
No, sir.
Right? Yeah. Right. So 1 second. Let me finish the attendance. Okay. Yes. Madhupi.
Yes, sir.
Mane Paniraj. Absent. Then Motion is also absent. Then Naman Shivananda. Naman. Srikanth is not there.
So, sir, I was there, sir.
Oh, okay, okay, fine. Okay, right. Okay, Pawan Kalyan, absent. Parthasarathi,
Present, sir.
okay. Rahul Rathod,
Present, sir.
Rajat M. Patel,
Present, sir.
Reni Sibbi.
Present, sir.
What, Reni Sibbi, where were you for so many classes? Sibbi, why didn't you attend the class, man? Huh? Sayam Govardhan,
Present, sir.
okay. Unni Krishnan, Rohan Unni Krishnan, is also absent. Yes, Stress, not there. And Shashank Varnasi. Shashank Varnasi, absent. Samarth Nadig. Samarth, absent. Banerjee. Sayanth Banerjee. Shashank KS.
Yes, sir. Present, sir.
Okay. Shashank MV.
Present, sir.
Shivkumar Patel. Shivkumar Patel. Shivkumar Patel. Shivkumar Patel not answering. So absent. Yes. Shri Harsha Prasad. Absent, not there only. Shubhankit Singh is also not there, absent. Okay, so practice these problems. Okay, do the problems. If there is anything, you please contact me. Okay, I will let you know. Right? Okay.
About the software, sir, it was coming like virus is there, sir.
That software virus is there.
Yes,
Is
sir.
it saying like that? Because that was the